Alright, welcome to the video on multiple bonds. Make sure you watch the video on single bonds first, or you're going to be completely lost, because this is just an extension of what we did in the last video. We talked about single bonds as being two atoms sharing 2 electrons. If you have 2 atoms sharing 4 electrons, you have a double bond. If you have 2 atoms sharing 6 electrons, you have a triple bond. There is no such thing as a quadruple bond. It stops at triple. So let's do an example of what that looks like for a molecule. Carbon disulfide. All right, we've been through the writing formulas from the nomenclature, so you should know by now that carbon disulfide would be CS2. Carbon has 4 valence electrons, like so. Sulfur has 6 valence electrons. The carbon's going to go in the middle because it's the oddball. Sulfurs are going to go on the outside. There's 6 valence electrons. Everybody wants to get up to 8 valence electrons, so we're going to bind those, and this one, and that one, and so we get carbon disulfide, like this. All right, let's walk through that in slow motion. Using our math. All right, CS2. Like I said before, carbon goes in the middle, sulfur goes on the outside. Here's our math. Carbon has 4 valence electrons. There's 1 carbon, so that's a total of 4 electrons. Sulfur has 6 valence electrons. There are 2 sulfurs for a total of 12 valence electrons. This gives us 16 electrons to play with in our compound. We start off by drawing single bonds to bond everybody up. We have to subtract 2 for each of the bonds we just drew, so 2 times 2, -4. So we're left with 12 electrons. Now we're going to count up our need. This sulfur is making 1 bond, so it's got 2 already. It still needs 6. This carbon is making 2 bonds, so it's already got 4. It still needs 4. This sulfur, again, has 2. It still needs 6. So our total need is 16, but our have is only 12. If our need is greater than our have, we need to make another bond. So we're going to go back to our picture, make another bond. Make bonds one at a time. Don't get crazy or you might overshoot. We're going to now subtract 2 more for our next bond. So -2 times 1. So now we're down to 10 for our have, but we need to recount our need. This sulfur is now making 2, so it is down to only needing 4 more. Carbon is making 2, 4, 6, so it is down to needing 2 more. So then 4 plus 2 plus 6, now we're down to 12. Well, we're closer than we were before, because before we were 4 away, now we're only 2 away, but we're still 2 away. So we need to draw another bond, because we need more than we have. So we're going to make another bond over here. We are going to subtract 2 again. So we're down to 8. Let's recount our need. This is still the same. I'm sorry, this is still the same. The carbon no longer needs any, because it's 2, 4, 6, 8. This sulfur has 4, so now it only needs 4. So now our need is equal to 8. Our need's 8, our have is 8. Now we're done. We can actually draw on the lone pairs. And carbon doesn't need any more. Sulfur needs 4 more, so we're going 1, 2, 3, 4, and 1, 2, 3, 4 for that. And that's what you get over here. All right, let's talk about a triple bond. That means we're sharing 3 electrons apiece. So for our triple bond, we're going to do the molecule nitrogen. You're like, whoa, wait a minute, nitrogen, molecule, nitrogen is an element. It's an atom. It's a diatomic element. So therefore, nitrogen and 2. And according to our periodic table, nitrogen has 5 valence electrons. So if we were to draw the Lewis dot diagrams, it would look like this. And then we want to bond up all our loners like that. Let's do this in slow motion. So again, we have nitrogen and nitrogen. Don't have to worry about who's going in the middle because there is no middle. There's only 2 of them. Nitrogen has a total of 5 valence electrons. There's 2 nitrogens. That gives us 10 valence electrons. We have to bond them to each other. We have to subtract 2 for our bond. That's 2, 1. We have 8 left. Count for our need. This nitrogen needs 6 because it only has 2. This nitrogen also needs 6. So our need is 12. Our have is 8. Not good enough. So now we're going to have to make another bond. minus 2. We have 6 left. Now, this nitrogen needs 4. It already has 4. This one also needs 4, which is 8. Getting closer, but still not there. So now we're going to need another bond. Subtract 2 more. So now we have 4 left. Now this nitrogen already has 6, so it only needs 2. This nitrogen also needs 2, so we only need 4. We have 4, we need 4. That's great, that's where we wanted to be. So we're just going to take our 2, put them on there, and that's a molecule of nitrogen. All right, next question. Can any old atom make a double bond or a triple bond? The answer is no. Only certain atoms make double or triple bonds. Typically. Now, there are exceptions always. If the molecule has to have an atom make a double bond that doesn't normally make a double bond in order for everybody to be happy, it's more important for the atoms to satisfy the octet than to not make double bonds. So if they have to, they will, but typically only 5 elements make double bonds. And those 5 are carbon, nitrogen, oxygen, phosphorus, and sulfur. How are you going to remember those 5? You use the Synapse monster. You're like, what on earth is a Synapse monster? Well, we take a monster and we give him an eye, and we give him a nose, and we give him a mouth, and we give him an ear, and another ear, and now we have our Synapse monster. Let's give him a little hair, so he's pretty. So Synapse is just a little visual representation of the atoms that can make double or triple bonds. Carbon, nitrogen, oxygen, phosphorus, and sulfur make Synapse. Now, as far as who makes double bonds and who makes triple bonds, typically all of these guys can make double bonds. These 3 guys in the middle are the ones that can make triple bonds. Again, there are certain occasions where an oxygen will make a triple bond. There are certain occasions where atoms that are not on the Synapse monster will make double bonds, but again, you can figure out whether that's going to happen if that is the only way to get the math to work out. The math has to work out. So in this case, we had sulfur and carbon, which are on the monster. In this case, we had nitrogen, which are on the monster. So those are the ones making the double and triple bonds. So you have to do the math just like you do for single bonds, and remember who gets to make double bonds and who gets to make triple bonds if you have a choice about it. Thank you.